Good morning, dear students. Today I am continue to the previous lecture. Today I am discuss second order differential equation. Now, first of all, you can note down the solution of second order differential equation. Differential equation. What do you mean by the second order differential equation? A differential equation, a differential equation having maximum second order derivative is known as second order differential equation. Differential equation is known as second order differential equation. Now, for example, d2y of dx2 plus p dy of dx plus q y is equal to r, where p, q and r are constant and r is only function of x. Now, there is a three condition belonging to this equation. Now, case number first, you can note down a differential equation do not contain x of the type d2y of dx2 is equal to f y. Case number second, differential equation which do not contain y of the type d2y of dx2 is equal to fx. Now, case number third, you can note down differential equation which do not contain directly y of the type you can note down d2y of dx2 dy of dx y is equal to 0. Now, case number fourth, this is x. Now, case number fourth, differential equation differential equation do not contain x directly of the type d2y of dx2 plus comma dy of dx comma y is equal to 0. This is the four condition of the second order differential equation. First of all, you can note down this condition. Now, again, I am discussing if the CF is known. If the CF is known, your differential equation solution. You can note down method of reduction. Method of reduction, or also you can known as if the CF complementary function is given, is known. This is a very important. First of all, you can note down this numerical. Let a differential equation d2y of dx2 plus p dy of dx plus qy is equal to r is a second order differential equation. If y is equal to u is the given CF of the equation, then the solution of differential equation equals to y is equal to uv. Therefore y is equal to uv is the solution of the given differential equation, and y equal to u is the first CF of the given equation. Since y is equal to u is the CF of the given equation, then dy of dx is equal to du of dx, or you can simply write d2y of dx2 is equal to d2u of dx2. You can write this. Now, if I let this is equation number first, we know that y is equal to uv, then dy of dx is equal to u dv of dx plus v du of dx, and d2u d2y of dx2 is equal to, you can write d of dx u dv of dx plus d of dx v into du of dx. Now you can write d2y of dx2 is equal to du of dx dv of dx plus u into v. You can use first and second of differential. Now you can write u d2v of dx2 plus you can write dv of dx du of dx plus v d2u of dx2. Now you can simply write u d2v of dx2 plus 2 du of dx into dv of dx plus v d2u of dx2. This is a value of d2y of dx2. You can note down the value of d2u of dx2, d2y of dx2 is equal to, you can write u d2v of dx2 plus 2 du of dx into dv of dx plus v du2 of dx2. This is a value of d2y of dx2. Now put these value in equation first. Now you can write in equation first, putting the value of dy of dx and d2y of dx2. Now you can write u d2v of dx2 plus 2 du of dx into dv of dx plus v du of du2 of dx2 plus p bracket u dv of dx plus v du of dx plus q and put the value of y is equal to u, v is equal to r, is equal to r. Now you continue to solve this equation. Solve this equation. You can write u d2v of dx2 plus 2 du of dx dv of dx plus v d2u of dx square dx2 plus p u dv of dx plus p v du of dx plus q u v is equal to r. Now to continue to this, you can write since y is equal to u is the function of complementary function. Now you can differentiate this function. You can write to write equation first, put the value of this. You can write d2u of dx2 plus p du of dx plus qu is equal to r is equal to 0. First of all, you can note down all the value of this form of equation. I am continuing to this step. You can note down in equation first putting d2y of dx2 dy of dx and value of y. You can write u d2v of dx2 plus 2 du of dx into dv of dx plus v d2u of dx2 plus you can write p bracket u dv of dx plus v du of dx plus q into put the value of y, it means u v. Since d2u of dx2 plus p du of dx plus q u is equal to 0. Now you can write v common, you can write first of all you can common the v, you can write d2u of dx2 plus p du of dx plus q u plus common of u, you can write d2v of dx2 plus common of u, you can write p dv of dx plus 2 du of dx into dv of dx is equal to r. Now put this value is equal to 0, you can write 0 in v into 0 plus u d2v of dx2 plus p dv of dx plus 2 du of dx into dv of dx is equal to r. Now you can write u d2v of dx2 plus p dv of dx plus 2 du of dx into dv of dx is equal to r. Now you can write d2v of dx2 plus common dv. This means you can write plus p dv of dx plus 2 upon u dv upon dx into du of dx is equal to r by u. Now you can write d2v of dx2 plus p plus 2 upon u du of dx into dv of dx is equal to r by u. Now let this is a differential equation of second order. Now let dv of dx is equal to z. Therefore you can write d2v of dx2 is equal to dz of dx. Now you can put this value, you can write dz of dx is plus p plus 2 by u du of dx into d into z is equal to r by u. This is a first order linear differential equation. This equation is known as first order differential equation. Now, I am removing the second order differential equation with the help of, first of all, you know, the first CF is given. Now you convert the first order linear differential equation. Now the solution of this equation is, first of all, you can find the IF. First of all, find the IF. And now again put all the value of Z and V. This is your V. Now, first of all, you can note down this numerical problem. This is a very important for second order differential equation method of reduction. If the CF is known, this is a second order differential equation related, some numerical related to reduction method. If the CF is known, please you can note down the first numerical problem. Find the solution of differential equation. Find the solution of differential equation. You can note down the differential equation. d2y of dx2 minus x square dy of dx plus xy is equal to x, given that y is equal to x is a part of CF. Now the solution of this problem, you can write, we have d2y of dx2 minus x square dy of dx plus xy is equal to x is a second order. This is equation number first. Is second order differential equation. Therefore t is equal to minus x square, 2 is equal to x, and r is also equal to x. Now, first of all, the reducing second order differential equation, is d2v of dx2 plus p 2 upon u du of dx into dv of dx is equal to r by u. This is a given and we know that. Now, if y is equal to x and the solution of if y is equal to x is CF of the solution, then let y is equal to xv is the complete solution of the differential equation. Is the complete solution complete solution of the differential equation. Therefore, put the value of P and U, you can write d2v of dx2 plus, put the value of P, this means minus x square plus 2 upon x into differential of this function. This means du of dy of dx, or you can write du of dx. You can write 1 into dv of dx is equal to r, this means x, and u, this means x. Now you solve this equation, you can write d2v of dx2 plus minus x square plus 2 upon x dv of dx is equal to 1. Is equal to 1. Now you can note down, this is a equation number second. This is a equation number second. Now again let dv of dx is equal to z, then therefore you can write this equation in equation second. We can write dz of dx plus minus x square plus 2 by x into z is equal to 1. Since this is equation number third, since the equation third is first order DE. Now first of all you can find the value of IF is equal to e to the power integration, the value of this means minus x square plus 2 upon x into dx. Now you can write e to the power minus x to the power 3 upon 3 plus log x square. Now you can write x square, you can write e to the power minus x to the power 3 upon 3 into e to the power log x square, or you can write the simply IF is equal to x square into e to the power minus x to the power 3 upon 3. This is your IF. This is your IF. Now the solution of this equation, now the solution of equation third is z into IF is equal to integration 1 into, put the value of IF, it means x square into e to the power minus x to the power 3 upon 3 into dx plus c. Now you can write z into x square into x to the power minus, e to the power minus x to the power 3 upon 3 is equal to integration of x square into e to the power minus x to the power 3 upon 3 dx plus c. Now first of all you can note down this numerical problem is related to the if the CF is known. I am continue to this step. Now you can solve this integration problem, z into x to the power 2 e to the power minus x to the power 3 total upon 3 is equal to, solve this integration x square into e to the power minus x to the power 3 upon 3 dx plus c. Let x to the power x to the power minus x to the power 3 upon 3 is equal to t, or you can write minus x to the power 2 dx is equal to dt, or you can simply write x square dx is equal to minus dt. Now put these value, you can write z into x to the power 2 e to the power minus x to the power 3 upon 3 is equal to integration. You can write e to the power t into minus dt. Now dt. Now you can write minus plus c. Now you can write z into x to the power 2 into e to the power minus x to the power 3 upon 3 minus e to the power t plus c. Put the value of t, you can write minus e to the power, put the value of t, you can write minus x to the power 3 upon 3 plus c. Now you again put z is equal to minus e to the power minus x to the power 3 upon 3 total upon x square e to the power minus x to the power 3 upon 3 plus c e to the power x to the power 3 upon 3 total upon x square. Now you continue, z is equal to minus 1 upon x square plus c upon x square e to the power x to the power 3 upon 3. Now you can write, since z is equal to dv of dx, then dv of dx is equal to, you can write minus 1 upon x square plus c upon x square e to the power x to the power 3 upon 3. Now integrate both sides. Now you can write v is equal to integration minus 1 upon x to the power 2 dx plus c integration 1 upon x to the power 2 e to the power x to the power 3 upon 3 plus c1. Now you can write v is equal to, solve this integration. Now you can write minus plus 1 upon x plus c integration of x to the power minus 2 into e to the power x to the power 3 upon 3 plus c1, or you can simply write now the complete solution of the second order differential equation, DE, y is equal to x into v. Put the value of v, you can write x bracket 1 upon x plus c integration x to the power minus x to the power minus 2 into e to the power x to the power 3 upon 3 plus c1. Now you can write y is equal to 1 plus x c integration 1 upon x square e to the power x to the power 3 upon 3 into dx plus xc1. This is a complete solution of the differential equation first. First of all, you can note down this numerical